I thought I moved it. Maybe I didn't move it there. Yeah, we were doing some enemy detection and that sort of thing, turning and facing. And I think we talked about using lerp for rotating and facing, and we'll kind of set up moving today, and that'll kind of wrap up what we've been working on. Just giving you guys some different tools that you can use. All right, so here's the project that we've been working in, and if we start this off, take this off. I can move, and when we get close enough, he slowly turns and faces us. Okay. If we are not in range, he turns and looks away from us, which we just have him looking at 000, which is the same thing as quaternion dot identity. Okay. Last class, we also looked at the idea of singletons. And so we have this game manager script that I'm going to pull up. And this game manager script is set up as a singleton. And here's how we create that singleton. And if you recall, the idea is that we force a single instance of it to exist so that we can access this instance statically, if that's a word. And because we can access it statically, it makes it really easy because we can access it through the class name. So, for example, when we are in our bad guy manager, which controls this red object, when we want him to face the player, we simply calculate the player's position and subtract from it his position. Okay, and the way we get access to the player is using that singleton reference. Okay, game manager dot instance, and the game manager holds a reference to the player, and so we can use that game manager reference to access the player. Okay, so this is kind of a review of what we did last class. We talked a little bit about vector math and subtracting two vectors. When you subtract two vectors, you essentially end up with a vector that is between the two positions. So lots of times you're going to need to be able to figure out a vector between 2 points. And the way you do that is by subtracting the two. And the order that you subtract them matters. So what we have here is we have a line from the bad guy to the player. And we want it from the bad guy to the player because we want him to look along that vector. Okay. If we wanted him to look the opposite, we would switch these two. Okay. So right now, when we do this, notice how the bad guy turns and faces us, and he always faces us. If we switch these two, and run it, he's now going to face the opposite direction. Okay, now he's facing away from us. See how that works? That's not what we want, so we'll put it back the way we have it. Okay? Questions? All right. What we will do from there, okay. What we will do from there is we can get our enemy moving towards us. Why don't we do that? Okay. So let's call this move towards target. So inside of updates, inside of bad guy manager, I'm going to put a new function called move towards target. Okay. As a general reason, as a general setup, it's good to separate the moving and rotating functions. that way they're not coupled together, and you can call them independent of one, which is good. And instead of calling face player, I'm going to call this face target, because I think that's a more apt description, because he doesn't always face the player. Sometimes he faces off into la la land. All right, so let's do this. Private, struggling to type, private void move towards target. Okay. And so this obviously requires that we are being given a target to move towards. And so what I'm going to do is up here, I'm going to declare a variable, say private transform target. Okay, and so what we're doing here is we are facing, or we want to be able to pass in a target, and we want to have it set up as a transform. We could alternatively simply use the vector 3 and have it instead of transform. You can do it either way. Vector 3 is contained in the transform as the position. The only time you would ever want to use transform here instead is if you wanted to get access to the target's rotation in addition to its position. Okay, so if you needed, if you wanted to get access to, like, let's say you had an enemy that was wanted to pursue where the player was going instead of where he was at that moment, getting access to the player's transform would give you more information, such as like the direction that he's facing, not just where he is. So typically it's set up as transform because it's more information, which is better. Okay. When we first start, we're gonna set target to null. I'm going to create a new, let's do this public void set target transform t. Okay, we'll set target equals t. So we set up this set target function that allows us to essentially set what we want this bad guy to pursue, both in terms of rotation and in terms of movement. And so let's modify our face target a little bit here. And then instead of necessarily referencing the player, what we can do here is we can have it based off of the transform that he references. So right when this first starts, I've got it set to null. What we probably want to do is go ahead and set it to the player. So we can say game manager dot instance dot player, wrong button, player dot player transform. Okay, so we'll pass in the player transform here. And then what we can do is we'll come down here and modify this a little bit. Okay, so we can say if target equals null, return. Don't do anything. If our target is null, do nothing. Continue to face the same direction. We could modify this to where if target is null, then we face off into the nothingness, or we go about some sort of, unaggroed state. Any of that would be fine. I'm just going to have him do nothing at this point. Okay. And then here, what we can do is we're going to modify this, and instead of saying towards player, we're going to make it more flexible, and we'll say it towards target. And instead of referencing the player here, we're simply going to reference the target dot position. Okay, because remember, target is a transform and position is a component of transform. So we'll say target dot position, and then from it we'll subtract trans. Now we don't have to worry about this being null, because if it's null, we're not going to get to this point. So we don't have to ever worry about not having a target and running this code and getting null references. So we're good there. Let's change this to this. So again, what we have here is if the target is too far away, then we will simply look off into space. If not, we will look right at the player. Okay. Now, general rule, this is like a general game development tip. When you make like refactoring changes like I just did, so I set it up to where we have a more generic approach where our bad guy can reference targets instead of only referencing the player. We made that change. We don't have any errors in our code. Instead of continuing to code and getting started with coding this move towards target, let's make sure that this works. Okay, whenever you make a change, make sure it works before you go on. And we want to make sure that we still are functioning the way that we should, and we are. So we're good there. Okay, any questions on the changes I just made? Okay. So now let's get into move towards target. So what we want to do here is we want to actually move our enemy towards the target. So we have a rotation speed up here. We're also going to need a move speed. Okay. We said rotation speed is 5. I don't know how fast are we moving the player? 4. So let's move the bad guy. Move speed equals 2. 2.5. A little bit, 2.5. Okay. All right. So what we are doing here is we want to move towards the player. Okay. And we're going to use similar logic to that. So the first thing, sorry for yawning. The first thing that we need to do is we need to calculate a vector between where the enemy is and where the player is, because that's essentially going to be the vector along which we want our bad guy to move. Okay, so we're going to do something very similar. So here we can say if target equals null, return. Okay, and if you look, we have something very similar here. This is a much cleaner coding style than doing something like this. So if target does not equal null, and then wrapping this entire thing in braces. Okay. This is not a good way to do it. It's better to do this. Okay. It's cleaner. It's easier to read. Do it like that. All right. And return just simply means stop. Don't run any more code. All right. So we're going to say vector 3 towards target equals, and we're going to copy that same code. Now, what is happening here is we are, make it, okay. So we have, this is the player, and then here is our bad guy. And what we are doing is we're taking the player's position, that's target position. Actually, let me do it. Get a different color. Okay, this is B for bad guy. That's this. We're subtracting these two things. When you subtract these two things, we get a vector that goes from one to the other. Okay. Questions on that? This is basic vector subtraction. Okay. So now we have essentially this line right here. This blue line is the vector between the two. And what we want to do is we want to move along that line. All right. Now, if we simply move along that line, we are going to have a hard time controlling how fast we move down this line towards the player. Okay. And we don't really care how long this line is. What we're interested in is its direction. Okay. And so what we're going to do here is we're actually going to do what's called normalizing this vector. All right. So what I did is I put this in parentheses. So the result of this subtraction is going to be normalized. And when we normalize a vector, when we normalize a vector, what happens is its magnitude, which if you remember last time, the magnitude of a vector is its length. The magnitude gets set to be 1. So the length of a line, the length of a normalized vector is always 1. And so we've effectively shortened the line. And we've shortened it because we didn't care how long it was in the first place. You know, how far away the enemy is from the player doesn't affect anything. The goal is to get the bad guys to there as quick as possible. So we don't care how far away he is, but we do care about the direction of the vector between the two of them. And by shrinking it and setting its length to 1, we could then multiply that to figure out how fast we want to move. And that's exactly what we're going to do here. Okay, so let me clear this again. So towards target. And what we're going to do is we are then going to take that normalized line and multiply it by a value that essentially corresponds to how fast we want to move that enemy. Okay, and so if we multiplied it by 1, we would be moving him 1 unit all the way down. Okay, which would be really fast when you consider we're running at like 60 frames a second. Okay, so here I'm gonna break this code out into some separate variables just to make it easier to read. All right, so let me comment this. This is towards target. Normalized vector pointing from the bad guy to the player. Okay, so normalized vector has a length of 1. Okay, the next thing I'm going to do is we are going to say new position. And so our new position is essentially where we want the bad guy to be next. Okay, and his new position is going to be his current position plus how much we want him to move. Okay, so this is going to be trans dot position. That's the bad guy's current position plus, say, towards target times move speed. Okay, towards target is the direction towards the player, and we're going to multiply that by the move speed. Okay. And I'm actually going to do this. Let's just do this like this. So the movement amount is literally how much we're moving in. Okay. Try to break this code down a little bit more simply. Now we'll see who remembers stuff from previous classes. We're missing something here. Okay, does anybody remember what we're missing? Specifically, that is not the button I meant to press. Specifically in this line of code, we're missing something. What is it? That's right. We're missing time.delta time. Whenever you are moving something, you want to multiply the movement speed by times.delta time. Time.delta time is the amount of time it took the last frame to execute. And so this essentially allows us to move consistently without worrying about frame rate. Otherwise, the faster the frame rate, the more these are going to move. Okay. So we're going to do the movement amount is towards target times move speed times time.delta time. Okay. Then we are simply going to do this. We'll say trans dot position plus equals movement amount. This is how much we want to move the bad guy towards the player, or towards the target, I should say. Move the bad guy's position. Okay. So it's literally 3 lines of code. You could do this in 2 or even 1 if you wanted to. Pretty simple. Let's see if it works. Okay. Now, notice what's happening. As soon as he's constantly facing us, or excuse me, he's constantly moving towards us. But it's like he's doing this weird Mario ghost thing where he looks at us only when he's close to us. And when we break that distance, he looks away from us. And when he gets close, he faces us, which looks really stupid. Okay. So let's fix this. What I'm going to do instead, if target equals null, then let's simply have him look off into space. Okay. So how we have it set up now is if the bad guy does not have a target, we're going to have him rotate and face 0, 0, 0, 0. He's just going to look off down the map. Okay. If he does have a target, then we will have him face the target. Make sense? Okay. For moving, if he doesn't have a target, he's going to stand still. If he does have a target, he's going to go after the target. Okay, so let's go back to this and run it. And so now he pursues us constantly. Also notice like the nice smooth movement we get. This is thanks to time.delta time. Now, what happens when he gets really close? We get this error right here. Okay, over and over again. Look rotation vector, excuse me, look rotation viewing vector is 0. And this happens whenever you essentially are trying to use look rotation and your two vectors are really, really, really close to each other. Okay. Most of the time, this won't affect your code. But if it is, if look rotation is essentially 0, then you just tell them not to do anything. Okay. You can fix that just with an if statement, but it won't affect it. Now, first of all, questions on that? Questions on what we've done so far? Okay. Okay. So let's talk about this, and if you have taken 4236, or you will take 4236, which is AI for games, we talk about this more there. But we'll talk about it here a little bit now too, which is the idea of a radius of satisfaction. And that's where kind of like once the bad guy gets close enough to a target, he'll stop, so he doesn't go all the way into him. There's a question in chat though. What is a quaternion? So we talked about this a little bit last class. A quaternion is a representation of rotation. It is the data type that is used to represent rotation in Unity. Most of the time, when we think of rotation, we think of it in terms of 3 components: an X rotation, a Y rotation, and a Z rotation. And that works for a lot of things, but there are some things that causes problems with. Without getting too much into it and talking about like Grimble lock and stuff like that, Unity on the front end, like the way we interact with it, uses rotation set up as XYZ, which is a vector 3. Okay. However, the way that it's run in code under the hood is set up as a quaternion. And a quaternion is a 4-part rotation that has X, Y, a Z, and a W. It involves, like, manipulating quaternions involves extremely high-level math that is well beyond the scope of anything you guys have done, unless you happen to be like a grad math student. But the good news is Unity does everything that you need in terms of quaternions. It does it for you, and so you don't have to mess with it. But that is the difference. A quaternion is a data type for rotations, is exactly what it is. Okay. Josiah, did that answer your question well enough? Okay. Keith, you said, what if I wanted to have multiple objects moving towards the player? Then you would simply duplicate this bad guy manager script. Okay. And we can do that. So for example, here, we don't even really need a reference to it here. What I would do is close out of this. So we have bad guy, and let's, yeah, so you could do it this way. Let's talk about the idea of prefabs. And so here we've got assets. I'm going to create a new folder and call it prefabs. Prefabs, so first of all, there are some built-in names that are special to Unity. And so if you do certain things in, like if you have a certain folder named prefabs, if you have a folder named editor, it will behave in a special manner inside of Unity. Prefabs is one of those. Like if you notice inside of, here's the Axis Football Project, there is a prefabs folder here, okay, where prefabs are used. Essentially what a prefab is it's the game object equivalent of object-oriented programming. So you have classes, like you define a class, and then from the class you can create multiple objects. Same thing with a prefab. It allows you to specify a prototype, and then from that prototype, create a bunch of different ones. And so what I'm going to do is I'm going to create a prefab out of our bad guy. And so I'm going to take bad guy, and I'm going to drag and drop him into this prefabs folder here. As soon as I do that, notice that he shows up in blue. That indicates that he is a prefab, okay? And so any changes I make to him can be applied to the base prefab, okay? But any changes I make to the base prefab are also going to get applied here as well, all right? And so prefabs work well when you have multiple of the same thing. So if you've got a game and you're shooting paintballs and you want to actually see the paintballs fly, it's good for those to be prefabs. When you get into a situation where you want a lot of variation between your prefabs, or between, like, let's say we've got a yellow enemy and a red enemy. Small variations are fine, but there's kind of like a fine line between, do I make a variation of a prefab or do I make a new prefab? And that's kind of, there's no right answer to those. I'll kind of show you both ways to do it, and then you can figure out what makes the most sense for your game, okay? And so let's look at this. We have a bad guy prefab, and then I'm actually going to delete the one in the scene, okay? And so what we can do is we can take this bad guy and then drag and drop him here, and we see it just pulls a brand new copy of the same one here. All right. I'm going to call this red bad guy. I'm also going to drag and drop another bad guy in here and call this yellow bad guy. And so on the yellow bad guy, I'm going to take this and I'm going to change the tint to make him yellow. Okay. And then I'm going to drag him over here. But you notice that when I do that, what happened? It changed both of them. Okay. And the reason it changed both of them is because they share the same material. Okay. And so this is where you get into a situation where prefabs aren't necessarily the best thing. If you want identical things, or maybe even small variations, prefabs can be okay. But if you want a good bit of variation, this is not what we want. Okay. And so, again, prefabs aren't bad. It's just they're used for very specific things. Okay. So I'm going to delete both of these, and I'm going to drag and drop this back into the game. If you have a prefab, see how it's blue, and you want to get rid of it, you decide you don't want it to be a prefab, just right click on it and then go down to prefab and then just say unpack completely. And that'll turn it back into a regular game object. Okay, and then we can delete our prefab. Okay. So if we wanted to have different kinds of bad guys, so this can be a yellow, and this can be a red. All we need to do is simply create different materials. Okay, so this will be our yellow bad guy material. I hit control, let me go back, sorry, I'm going too fast. We have yellow bad guy material, and then I hit control D and duplicated it, and this would be our red bad guy material. And then all I'm going to do is simply change the tint to red. Okay, now it changed both of them again. The reason it changed both of them is they're both still using the same material. So we click on the red bad guy, and see in the mesh renderer we have assigned to it the red material. So we'll click on the yellow bad guy, and we're going to drag and drop the yellow material to him. Bang. Now he's yellow. Okay. But notice this, red and yellow both have the same bad guy manager script. Okay. So let's pull up that bad guy manager script. And if you remember, what we did at the very beginning is we set the position to be based off of the player's position. We don't want this to be the case, because if we did this, they would both start in the same exact position. We don't want that. So I'm actually going to delete that. Okay. And what we'll do is we're not going to set its position at all in start. And instead, we are going to let wherever we put them in the editor be their starting position. Okay. So which way are we going? Okay. So we'll have the red guy here. Let's move him over here. Let's take the yellow guy. Let's move him over here. And we'll take the player and we'll move him back here. Okay. So when we start, they're both coming at us. Okay. It's very scary. All right. So let's take this one step farther. Well, actually, let's run this and see how this works. All right, both using the same code to follow us. All right. Those of you new to games, this is how you kite things. Get them all lined up. Okay. Now, if you notice, they move at the exact same speed. What we can do to add a little bit of difference between the two of them is we can have them move at different speeds. Okay. So if you notice up here, what I've got is our move speed is a private variable, which means we're setting it in code inside of the script, which means all of our bad guys have to move at the same speed. All right. What we're going to do instead is I'm actually going to take that move speed variable and I'm going to serialize it. All right. It's still private, but I no longer am going to set it here. I'm no longer going to set it in code. Instead, what I'm going to do is I'm going to set it in the inspector. So remember, when you put serialized next to a variable, that causes it to show up in the inspector. Now we have move speed. Notice how it's set to 0. Okay, it's set to 0 because that's the default float value. If I give it a value of, let's say, 2.5, and then go back to the inspector, it should give it. Normally it defaults to 2. Whatever value you set it here is what it defaults to. Oh well. Either way. Let me try that again. That's weird. Oh well. Either way, what we can do here is we can now set the speed. So we'll let the yellow guy move at 2.5, and we'll have the red guy move at 3.5. So now we have a little bit of variation between the two. Notice how much faster the red guy is now. Still running the same code, but he's much faster. Okay. Questions on this so far? All right. Now let's talk about the idea of radius of satisfaction. So radius of satisfaction will, and if you think about its terms, radius obviously refers to, we got some sort of circle, and we're looking at a distance from the middle of the circle. So the radius of satisfaction is when I get this far away from something, I've essentially satisfied my goal of moving to it. And so I'm going to say I'm done there. Okay. And so here we'll declare a new variable, say radius of satisfaction. And we'll set this equal to 1. I don't really know. We'll play with the number and see what we get. Okay. So as we are moving towards the target, what we want to do is we want to stop if we get within that radius of satisfaction. We just want to stop moving. Okay. This will also prevent, and some of you might have experienced this when, and we don't see it here, but if we have a move faster, we will. So let me show you an example. I'm going to increase the player speed a lot, or the enemy speed, and watch what happens when he gets close. Oh, he's not doing it. Let me increase it even more. You see what the red guy's doing? It's hard to see. Let me increase it just a little bit more. Yeah, he's shaking back and forth. Okay, he's got the jitters. This happens when, because essentially what's happening is he's saying, I need to move to the middle, or he's trying to move to the position, but he's moving so much that he actually moves past where he's trying to go. And he moves past where he's trying to go, and then the next frame, he's trying to get back, and so he moves past again where he's going. He's just constantly shifting back and forth. And this is no good. And you get this wiggle a lot when you're first setting up something like this. And so what we want to do is setting up a radius of satisfaction to prevent this from happening. And so inside of our bad guy manager, we've got this radius of satisfaction set to 1, and we're simply going to check it out here. Okay, so as we do this towards target, we can do this a couple of different ways. The first thing we can do is simply check the distance between the two. All right, and so we can say if vector3.distance, so vector3.distance is a built-in function, and it wants 2 different vectors. And so we're going to take the position of our bad guy and the position of the target. If that is less than the radius of satisfaction, then we are going to do nothing. Okay, this is one way to do it. Okay, do not move if inside of the radius of satisfaction. All right. Moving, they're moving, they're moving, stops. I guess 1 wasn't a bad value. Oh, what happened?
You fell off.
We got pushed off the edge. I'm not controlling, I'm getting pushed.
Is there some sort of rigid body attached to them?
Attached to the player. I'm going to remove it. We'll talk about rigid bodies in just a second. So the radius of satisfaction stops 1 unit out. So that was a good guess. Notice how once I took off the rigid body, we no longer get pushed. Okay. All right, any questions on radius of satisfaction? It's pretty simple. If the distance is less than, distance between the two positions is less, don't do anything. Okay. All right, now let's go back to that rigid body. So I removed the component, I'm going to add it back in. All right, so I'm going to add a rigid body. And a rigid body essentially gives this guy, whatever object it's attached to, it gives it physics properties. Okay, and it works in conjunction with its colliders. And so, and we saw him get pushed a minute ago, but notice what happens. He doesn't get pushed when the one guy hits him. It's not until both push. But notice here, it's the yellow guy's pushing him at like a slight angle, but as soon as they're kind of facing the same direction, then they have enough to push him. Okay. But these guys don't have rigid bodies. Okay, and we could add them. So I added rigid body components to both of these, and you can specify like the mass and the drag and all that sort of stuff. But notice how they won't bump into each other anymore. And I'm like pushing against them. It's like bumper cars. So this is the nice thing, like Unity has a built-in physics engine, works pretty well, as you can see. Trying to tip him over. Tip over. See if I can push him off the edge. This. Well, off the edge. We got one. See if we can get the other one. And we made a sumo. Oh no, almost. I've got this. This is difficult. We won. That should be our game. Sumo game. All right. Questions on this stuff. What questions can I answer for you guys?
So for like, because I'm gonna have some sort of like attacking function in my game, and I know you probably will go into that later. Rigid bodies, would that be important when it comes to like colliding with individuals or like like a game object taking damage and stuff like that.
No, you don't really need rigid bodies for that. Like if we take off the rigid bodies, so here's the thing. Rigid bodies are for when you need realistic physics. You don't need rigid bodies for collisions. Okay. You do not need rigid bodies when you are simply detecting collision between two things. And so if you have a sword that you're swinging and you need the sword to hit or to detect when it hits something, you don't need rigid bodies for that. Rigid bodies are for when you have you need to simulate real physics like acceleration, momentum, like shapes colliding and reacting as appropriate to their structure. So like if you have a circle that lands on a square and you want it to, bounce and roll correctly, you need physics for that. But if you've just got like a, like a standard, you've got a character and you're running around and he's swinging swords and I need to be able to hit things and detect that, you don't need rigid bodies for that. If that answers your question.
Yes, it does. Thank you so much. I appreciate it.
Yep.
I just had a quick question, sort of in the same vein. I want to do something with like grid-based movement, and I was wondering if because I want something to where like they move to like each space on the grid, with sort of like a force. I was wondering if rigid bodies would be like useful for that.
Yeah, if you need to use force, you have to use rigid bodies. And so it's just there's a method simply called add force that adds force in a direction that you specify. You can do that, but it's not necessary. Like you can simulate that with just moving, like for example in Access football, the way I used to snap the football, like the ball literally travels from the center back to the quarterback. I used to use add force in the direction, but I don't anymore. I move it by moving its transform position just like this. And so you can do it either way. What I will say is using physics, I have found, is more temperamental. It doesn't always do what you want it to do or what you think it should do. And so I have found it is easier to simply move the position rather than using add force. But there's different ways to do it. And one's not necessarily better than the other. That's just my take on it.
All right, thank you.
You're welcome. Other questions? Okay. Well, I'm trying to think what would be beneficial for you guys. Are you guys doing jumping in your games? Anybody doing jumping?
Yes, I would like to have some jumping in my game, yes.
Okay. We can look at some different jumping. And jumping is a situation to where using a rigid body does make it easier. Manually coding how to do, or manually coding a jump upwards is very difficult. Not difficult, it's tough when you're not using rigid bodies. You can do it. I mean, trying to think what to cover. So essentially, here's how this works. I'll explain how to do it both ways. If you don't have a rigid body, and so what I'm going to do here is I'm going to take these two guys and I'm just going to hide them. Okay, so when we run the game, we get nothing, just this. If you don't have rigid bodies, you have to manually code the jump. And I say it's more difficult. It's not as bad as I'm making it out to be. but I'll show you how to do it. Okay, so we're going to say private float jump speed. Okay, again, we're in player manager now. Okay, so we'll say jump speed equals 5. I honestly don't know if that's a good number or not. Okay. And then we'll say if input dot get key code dot space. We'll jump with the space bar. Okay. Then we will say do jump. Now, private void do jump. With the jump, there's a couple of different ways that you can set this up. Generally, the idea is you can only jump once, like no double jumps, unless your game has double jumps, then you need to modify this code. Okay, so if we are jumping, we need to keep track of whether or not the player is on the ground. And we only want them to jump if they're on the ground. And so there's different ways to do this. You can have it to where you check the player's Y position, and if the Y position is close enough to what we consider on the ground, then we'll say he's on the ground. You could also do it based off of actually colliding with something that we have tagged as a platform. Okay. I apparently can't spell. We're going to do it because we have a consistent plane. We're going to do it based off of Y position. Okay. And so what I want to do is when we first start, see, notice our normal height is 0.5. Okay. And so I'm going to change that from normal height to ground height. That is the height of the ground. Okay. Now, let's do this first. So if player is on ground. Okay, so I've got a function here that returns true or false, depending on whether or not the player is on the ground. Okay, so we'll say if player transform dot position dot y is less than or equal to ground height, return true, otherwise return false. Good so far? So if the Y position is on the ground or below it, then we will say he's on the ground. All right, I'm going to simplify this code because this is ugly code and just say return make sense? So it's either this statement is going to evaluate either true or false. If it's true, we say yes, the player is on the ground. If it's false, we'll say no, the player's not on the ground. Okay. So if the player is on the ground, we want to do the jump. All right. And what we are going to do is we are going to want to initiate, and here's how this works essentially. While the player is jumping, we are constantly moving him up and constantly moving him down. And the way we are doing that is we move him up at a consistent speed, but we increase the effect of the gravity on the player. Okay, that's essentially how this works. And so we constantly are going to move the player down if they are not on the ground. All right, so we'll say if player is on ground equals false, then we are going to move the player down. All right, and so we're going to say player transform dot position plus equals gravity. Okay, so now we need a new variable called gravity. Private float gravity. And initially, we're going to set gravity equal to 0. Okay. When we do the jump, we're going to set gravity to 0 again. Because again, the idea here is we're going to move the player up at a consistent speed, and down at an increasing amount. So eventually what happens is as the player jumps up, we're constantly moving them down with gravity, but gravity is increasing over time. So at some point, gravity is going to overtake the amount that we are moving the player upward, and then the player is going to slowly come down. This creates kind of like a rubber band effect rather than a straight up, straight down kind of jump. Okay, so we're going to slowly go up, and then we kind of reach that pinnacle where gravity takes over, and then we're pulling them back down. Okay, that's how we do this. So when we do the jump, we set the gravity equal to 0. Okay, and we are going to, why does it like this? Okay, so we're going to move him down based off of gravity 0x 0z because gravity is just up and down. Okay, so we're moving the player down. This is the gravity amount, and we're also going to increase gravity by 0.1. Wow. We'll leave it like this. Let's do a fault speed variable. And let's set it equal to, I'm going to start with 1. I really don't know if that's a good value or not. This essentially represents how fast the player falls. Okay, so we'll say gravity plus equals fall speed times time dot delta time. Again, anytime we're moving the position inside of update, we need to multiply by time dot delta time. All right, so here, and it doesn't matter which of these goes first because this is going to run a bunch of times. So here we set gravity, as soon as the jump is initiated, we set the gravity to 0. And we're going to initiate the jump with the player. Okay. As the player is moving up, we are going to move them down with gravity. And so this is what's responsible for moving the player. Move player down with gravity. And then we are going to move player up with jumping. Okay. So we'll say player transform dot position plus equals new vector 3 0f, and we'll say jump speed times time dot delta time. Okay, that's going to move the player up. Questions so far? All right, now there is one issue with this code. All right, so the way this works is we hit spacebar and we do the jump. And if the player is on the ground, then we are going to start the process over of jumping. I think it makes more sense. Let's have a variable called is jumping. This is going to make things cleaner. So when we start is jumping equals false. And when we press the space bar, we are going to do the jump. So if the player is on the ground and is jumping equals false. Okay, and this is player on ground isn't even necessary, really. I think we can get rid of this. We'll leave the code down here in case we want to call it in just a second. So here we'll say is jumping. So let's run through this code real quick. If the user presses the spacebar, we're going to call this do jump function. If the player is not already jumping, then we're going to initiate a new jump. We do that by setting gravity to 0 and is jumping to true. Okay, the reason we set gravity to 0 is because every time we start a new jump, we want to start the amount that we're moving down over again. Okay, so then that causes this if statement to be entered. Okay, gravity starts at 0, and we're going to slowly increase the amount of gravity based on the fall speed, okay, which we have this set to 1. So gravity is going to slowly increase from 0. Then we're moving the player down based off of this. We actually want to subtract here because that's going to continue to move them up. All right, so gravity we want to move down, and then the player's position, we are going to set the Y value based off of the jump speed. And jump speed initially is higher than gravity, and so we're going to see it moving up, and then eventually, because gravity is increasing, we're going to see the player move back down. Okay. We are missing one thing on this, and what is that? Anybody know what we're missing here? We're missing a check for something.
Is it whether we're in the air? Because I'm kind of imagining something where you can go up, 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 up. Just
Well,
by jumping endlessly, like
Close.
I can turn on my computer, my camera to show you.
No, I know what you mean. If so, here, when we press spacebar, we only do the jump if we're not already jumping. And maybe it's easier to do this. If, let's put this here, is jumping equals fall. So if we are not jumping and we press the spacebar key, then we can do the jump. So we can remove this check here. Okay. All right, in the interest of time, we're gonna do this. We need to check for the player hitting the ground again, because we're moving him up and we're moving eventually back down. We need to check to see when does he hit the ground, because we need to reset is jumping to false. And so this is where that function will come into play. So we'll say if player is on ground. So if we have moved him down to the point where he's now back on the ground, we're going to set is jumping to false. And we're going to put the player back on the ground. So we'll say player transform dot position equals new vector 3 0f ground height 0f. Right. Now we can't do this code like this, because what would happen is we would automatically snap back to 0x and 0z. And this is no good. So what we want to do is we need to actually take the player's position of x and keep it the same, and z and keep it the same. Okay, see what I did there? And we don't have to do that here because we're adding on to the player's position. But when we are explicitly setting the position, we need to take the current x and the current z. Okay, so let's go back here. We have our bad guys turned off, and let's see if this works. Ready, set. We jumped a little bit. What happened? It's like he's trying to jump.
How high did we set the position of the jump to be?
5.
Well, I said to like 50 or something.
Yeah, so there's two things that are probably happening here. The first is probably we aren't moving him up enough, and as soon as we jump, the game thinks that we've hit the ground again. Okay, and so if we take jump speed and we set it to 50, this should give us an idea of if that is the problem. All right, so what do we see here? What's the problem?
They're
We're
moving
jumping.
too fast.
What's moving too fast?
The falling part.
That's right.
Yeah, what Aiden said.
Yeah, the gravity is way too strong. All right, and so we're going to take gravity, or take fall speed, and we're going to set this like 0.1. All right. And again, you just have to play with these numbers. Are we multiplying by? Yeah, we are. Just making sure. Ooh. Okay. Works pretty well. Makes me want to puke. Let's adjust the jump speed back to, let's do like 10. All right. Not super high. So I still think gravity is, or the fall speed is too high. So let's do it to like 0.02. And this is where you can kind of control what kind of jump you want in your game. If you want a more responsive up and down, then you need high jump speed, high gravity, or high jump speed, high fall speed. If you want more of a floaty kind of jump, then you'll do a much lower fall speed, okay? So here we have a much more consistent, this isn't bad. So if you want them to jump higher, then you need to increase the jump speed. Okay, so if we increase the jump speed to 20, we're still going to fall at the same rate, but we're going to jump much higher. Okay, so again, one's not, I'm not saying that, you know, there needs to be a certain ratio between jump speed and fall speed, but you kind of see how they interact with each other. Notice also kind of like the slow up, and like we start off fast, but as we get close to the top, the gravity starts to take over and then we sling back down. This is different than like a straight up, straight down type movement that you would get if you simply like hard coded the jump. Like we're going to move up for 30 frames and then down for 30 frames, and we're going to move the same amount of distance. That's not the best way to do it. You get a much better looking jump with this. Okay, and so I think probably 15 would look a lot better.
Is there a way to anchor the camera to the ground just when the object is jumping, so you don't get like the, what you say, if you wanted to minimize the whole kind of bounciness aspect of it?
Yeah, if you wanted to do that, you can kind of I mean, there's a lot of different things you could do. You could lock the player's Y position. And so if, like, this is inside of Camera Manager. If you didn't want to ever move the Y position, you could simply set a consistent Y value here. Instead of taking the player's entire position, you would do something like, just in the interest of this, is like float Y position equals, maybe we want it stuck at like position 5. Okay, and so the camera end position is say new vector 3. We'll take the player's X position, we'll take the saved Y position, and then we'll take the player's Z position like this, and add the camera offset. You could do something like this. So now it's going to be 5's too high. Let's do 3. Three's still too high. Now when he jumps, the camera doesn't move up and down. Okay, it'll still follow the player, but you get a much better. Makes sense. So that's all you do. You just have the Y position stay constant. You don't take it from the position of the player. Cool.
Thank you, Professor.
You're welcome. Questions? Okay. All right. We'll wrap up here with this today. Shut off screen share. So a couple quick reminders.